All right, so in example 6, we're actually going to integrate some trig functions that we don't have the integrals memorized for. So one example would be tangent, and you can actually do cotangent very similar to this. But we're going to break up tangent into sine over cosine. And then we can use u substitution. Oh, that's still an x. So u is going to equal cosine of x. Du is negative sine x. And so when we do u substitution, dx is replaced with negative du. So I put the negative on the outside, 1 over u du. So it's negative natural log of u plus c. And so we will put the cosine back in, negative natural log of cosine of x plus c. So again, you can do cotangent in a very similar way. You would have cosine over sine, and so your u would be the sine in that one. For b, the integral of secant, this one's special. There's actually someone who figured this out, so you don't actually have to know this, but because I'm telling you this, you'll know to try this from here on out. But you can actually multiply the numerator by secant plus tangent, and then we're going to do the denominator by secant plus tangent. The reason we do that is when we multiply it out, the numerator becomes secant squared plus secant times tangent. Both of those, one of them is the derivative of secant, which is our denominator. So secant tangent is the derivative of secant, right there. And secant squared is the derivative of tangent. So by multiplying by that, we make u substitution possible. So we would make u secant plus tangent, and du would be secant tangent plus secant squared, which is what we have in our numerator. And u substitution would be quite easy. So it's 1 over u du, natural log of u plus c. So my final answer is natural log of secant plus tangent plus c. And so very similarly, you could do cosecant. Instead of multiplying by secant plus tangent, you would multiply by cosecant plus cotangent. But you can see in the notes that you have on your paper right here, it has all of those written out, what the the integral of each one would be.